All right, welcome back. Today we start 1.3, which is about polygons. So now that we've talked about points, lines, planes, angles, we're now going to start to build some pictures off of that and work some problems with those pictures. So to begin, we've got the definition of polygon, which says is a closed plane figure, meaning it's going to be two-dimensional. It's going to be on a flat surface. It's also closed, which means it's not going to be, like you can see this polygon down here, it doesn't have any holes in it. It's all closed up. Formed by three or more line segments that intersect only at their endpoints. And I've got a little list here of all the different types of polygons we're going to be working with. From 3 to 10, you definitely want to know these. 12, this is kind of a little bonus one, dodecagon. I'm not sure why that's special enough to include here. But normally after 10, again, you don't really need to know that one, but after 10, we normally just call them an n-gon. So like say they have 20 sides, we might call that a 20-gon, just for simplicity. So if you look over here at the picture, this one says, what type of polygon is the figure below? Name it. It is a quadrilateral. It's got 4 sides. And if we were to name it, now some of you might say, well, that's a parallelogram, but since I don't know the measure of those angles, I don't know the measure of the sides, I can't say for sure that it's a parallelogram. Really all I know is it's got 4 sides, it's a quadrilateral. So when we name this, we would name it polygon, or you could say in place of polygon, you could name it quadrilateral. That would also be acceptable. Polygon or quadrilateral, and then you name it by the letters of the vertices. And you got to name it in the order that they go. So we could call this polygon A, B, C, D, or quadrilateral A, B, C, D. You don't have to start at A. You could start at a different letter. You could go B and go B to A to D to C. Since B to A to D to C, connect in that order. But you couldn't, here's a non-example, you couldn't go AC, BD, because that's not the same thing. So you need to go in the order that they're connected. Again, any order, it doesn't really matter, just as long as it's in an order that they're connected. So kind of moving on here, we're going to take a look at 5 different pictures and determine whether each figure is a polygon. And I'm going to be using this definition here. Closed, and I'm going to underline some key parts. It's got to be closed. It's on a plane, so it's two-dimensional. You're not going to worry about that too much. 3 or more line segments, and they intersect only at their endpoints. So let's look at this picture here. So A, we just kind of covered that one. Yes, that is a polygon. In fact, that is a quadrilateral. B, however, is not a polygon because it's not made of line segments. You know, this is a segment, but this is a curve, which is not a segment. So that one is not a polygon. This one, the lines actually extend past the endpoints there, so they're not intersecting at their endpoints only, so this is also not a polygon. D is a polygon. In fact, it's got 1, 2, 3, 4, 5, 6 sides. So this would be a hexagon specifically. And then lastly, the star here out at E is not a polygon because it doesn't intersect at just the endpoints. If you look right there, that's not really an endpoint. They're intersecting in the middle of 2 line segments. Here's one line segment, here's another line segment. They're intersecting not at their endpoints. The same reason C is not a polygon. We've also got down here, draw the polygons described below, then classify and name the polygon using the vertices. So here we go. This is a polygon with 5 vertices. So if you think about 5 vertices, we're talking about a pentagon there. And again, you can draw it however you want. 1, 2, 3, 4, 5. That's how I'm going to draw this one. And I'm going to name it pretty simple. A, B, C, D, E. So that would be pentagon. A, B, C, D, E. Let's change colors here. Let's go to B. B, a polygon with 4 sides of different lengths. So we'll say there's a side, here's a really short side, Here's a really long side, and kind of also a medium-sized line. They're all different lengths. And we would call this quadrilateral since it's 4 sides. And let's use some new letters. Let's go F, G, H, I. So this would be quadrilateral. Oops. Run no space there. Quadrilateral, F, G, H, I. And then last but not least, on our third one, again, we'll change colors one more time here. A polygon with 6 sides of equal length. Now, this is going to be pretty tough to get 6 sides equal length, so I'm going to try my best here. That's going to be a hexagon. And we're just going to go here, 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 here. That's pretty close. Now, I know they don't all look the same side, but one thing you could do is you could put tick marks on each side just to kind of demonstrate, hey, these are all the same. So that would be, again, let's use some new letters. Let's call that J, K, L, M, N, O. So this would be hexagon. J, K, L, M, N, O. If we're naming it. By the way, if all the sides are the same and all the angles are the same, we actually have a special name for that. That is called a regular polygon. So here I have a picture of a regular pentagon. You can see all the sides are the same and all the angles have arc marks, a single arc mark. So they're all the same. And that is called a regular pentagon. So down here, just telling you if each polygon's regular or irregular. A would be irregular because we have these 2 sides the same, but these 2 sides are a little bit longer. They have double tick marks. So their angles are all the same, but the sides are not. So that would be irregular. B would be regular. All the sides have 1 tick mark. All the angles have 1 arc mark. In fact, that is a regular hexagon. Again, we just got done drawing one of those. And then C, you know, if you look quickly, it looks like all the sides are the same, all the angles have 1 arc mark, but they didn't mark these angles. Those are actually called reflex angles when they go over 180 degrees. So this is also irregular. Maybe we'll put double arc marks around those, because they are much, much wider than the other 4. Last thing today is we're going to talk about making these shapes and doing area and perimeter. Hopefully you know how to do area and perimeter. You've probably done them before, but just to go over them again, area is kind of the space inside a figure, whereas perimeter is the distance around an object. So for perimeter, you're always just going to add up all the sides. For area, you've got some unique formulas for, so for instance, a triangle formula, 1/2 base times height for area. If you're doing a rectangle, length times width. If you're doing a trapezoid, trapezoids may be new to you. They have theirs written as height times base 1 plus base 2 divided by 2. I kind of like to rewrite that. Me personally, I like 1/2 to go out in front, base 1 plus base 2 to go in the parentheses, and then multiply by the height. That's the same formula. Just really a matter of how you'd like to write it in. But just know that a trapezoid has 2 bases, and the bases are actually the parallel sides. So like that would be a base, and this would be a base, the parallel sides. Last thing I'll mention here with these formulas is that the height is always perpendicular to the base. So for a triangle, you could use any side to be the base, but if you use any side to be the base, the height needs to be perpendicular to it, meaning it needs to make a right angle with the base. Same thing with rectangles. Some people like to call rectangles base times height instead of length times width. So if you call this the base, this the height, they will make a right angle with each other. Same with trapezoid. Height is a perpendicular to the bases. So keep that in mind as you do some of these problems. And I've got about 5 examples, and this is where we'll finish today. So It says find the perimeter and area of each, starting with number 1, a rectangle in which the length is 17 and the width is 5. So if I were doing perimeter for that one, I could take 17 plus 17 plus 5 plus 5. Those would be all 4 sides. And the perimeter there would be 44 centimeters. Area for that problem would be length times width, or 17 times 5. If you have a calculator, it will go faster. 17 times 5 is 85, so we would say the area is 85 centimeters squared when you do an area, since it's a two-dimensional space. And that would be for number 1. Let's switch colors here for number 2. A triangle in which A is 8, and you can see I've got my picture here. I'm just going to write in 8. B is x plus 1. C is 4x. And H is 6. So I've kind of written in all those different details. So if we're going to do perimeter first, remember that we would add up all the sides. Now, the height is not one of the sides, so don't add that one in there. But we would go perimeter, 8 plus 4x plus x plus 1. And you would want to combine those like terms here, so your perimeter would actually come out to be 5x plus 9. And that would be it. You'd have to leave it that way because we don't know what x is, and there's not really a way to find it right now. So that would be your ultimate perimeter. As for your area, be 1/2 base times height. Your base, remember, is x plus 1. Your height is 6. Now, again, you can multiply this in any order you want. I would probably take the 1/2 times 6 first and get 3. So then it would be 3 times x plus 1. And that would leave my area as 3x plus 3 if we distributed the 3 to both. So that would be your perimeter and area. Maybe I'll circle that one. Changing colors one more time. Let's do number 3, a square with a side of 3.5 inches. Hopefully everybody knows a square has 4 sides that are all the same. So if you were to add up the perimeter on this one, 3.5, 4 times, you would get a total of 14 inches. The area would be length times width. In this case, the length and width are exactly the same. So 3.5 times 3.5, or 3.5 squared. That would be 12.25 inches squared. And then if you go on down here to the bottom, I have some unique pictures here. Number 4 says just find the area of parallelogram PQRS. Number 5 says find the area of that strangely shaped pentagon. And when you get it like this, you know, a parallelogram is not a shape we covered, but it is on a coordinate plane. So one thing that may be helpful is to cut it into shapes you know. Like in this scenario, I'm going to cut this into 2 triangles. I'm going to use this as the height of the top triangle. I'm going to use this as the height of the bottom triangle. And you can do that a little bit easier. So starting with the top triangle, 1/2 base times height. I'm going to use PR as my base. So I'm thinking, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 would be the base. And the height, 1, 2. 1/2 times 10 is 5. 5 times 2 is 10. So the area of this top triangle is 10. The area of the bottom triangle is exactly the same. I would be using that same base. Again, this would be my height right here. So it's also 10. And you can add those areas together to get the area of the full parallelogram. So the area here would be 20. And we'll say units squared for this. Could just leave it as 20. That wouldn't be a huge problem. And then lastly, going over this one, again, break it into shapes you know. I would also try to use those little points that they gave you, like here, 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 here as kind of your ending spots. So for me, I might draw a line going across here. That's going to make one triangle. I might go straight down from here, make another triangle. I could do another triangle here, and then the bottom would be a trapezoid. But if you wanted to cut it one more time, you could cut it into a square and a triangle if you'd like. I'm going to kind of leave it like that just so we get to do a trapezoid. And we'll kind of do area of each one of these triangles here. So 1/2 base times height. So we're going to be following the same thing. I'm going to start with this triangle right here. The base would be 3, the height would be 4, so that is an area of 6. We'll go down to that very bottom triangle. I'm going to use this as the base right here. Base is 2. Height would be 5. 1/2 times 2 times 5 is going to be 5 units. Move to that top triangle. Again, base of 2. I'll throw on the right angle. Base of 2, height of 5. So again, an area of 5 there. And then you got the trapezoid here in the middle, and I want to do one formula with the trapezoid. So again, I'm going to highlight your bases in green here so you guys can stand out. So that would be a base. This would be a base. Those are your two parallel lines, which would make your height right here. We'll kind of leave it off though for now. The height's 2. So if I added those bases, you would go formula, area, 1/2, base 1, which was 5, base 2 was 2 units, times the height, which was also 2 units. 1/2 times 7 times 2. Again, I would probably take the 7 times 2 first and get 14. So 1/2 times 14 would be 7. And again, I would call that units squared for area. And that's really what this lesson's about. It's just kind of working with area and perimeter of some simple shapes, but also working on the names of those shapes, how to write polygons, what is a polygon, what isn't. And that's a wrap for today's lesson. Make sure you do your homework, and I'll see you in class tomorrow.